Hi, I'm Tim Crow, Assistant General Manager of the Nevada Irrigation District here in Grass Valley, California. We are embarking on a project that uses new, innovative technologies to remove mercury from contaminated sediments in the Bear River. The district's canals and reservoirs lie immediately downstream of many historic gold mining activities of the 1850s. Today, mercury from that gold rush era is a source of methylmercury contamination in many of the Sierra Nevada rivers and streams.
The Bear River Watershed Group is comprised of a diverse interest group of stakeholders that care deeply about the watershed health. We support this project as it improves water supply by removing sediment from Lake Combie, and it improves water quality by removing and reducing the amount of legacy mercury in our riverine systems.
That same mercury from the gold rush era is a source of methylmercury contamination in many of the Sierra Nevada rivers and streams.
Essentially, 26 million pounds of mercury were brought over to the Sierra reservoirs during hydraulic mining, and 10 to 30% of that mercury was lost to the environment, making it a very messy process. So though that happened 150 years ago, we still have mercury moving down the Sierra rivers with each storm event because it is essentially entrained in the river gravels.
Mercury can be methylated by bacteria at the bottom of the food chain. Once mercury is incorporated into the food chain, it moves up the food chain as bacteria are consumed by phytoplankton, and phytoplankton are consumed by filter feeders, which are all eaten by the fish. Mercury becomes more concentrated with each step. Large predatory fish, such as bass, often have high levels of methylmercury because not only have they eaten a lot of smaller fish, they also live a long time, allowing the mercury to accumulate in their bodies. As a result, there are numerous fish consumption advisories for Sierra reservoirs.
This project is to remove accumulated sediment in the upper reaches of the reservoir while implementing a best management practice to remove mercury from those sediments. Well, those river gravels accumulate in impoundments such as Combie Reservoir, and irrigation districts such as the Nevada Irrigation District have to maintain the water storage space in the reservoir. This brought up the opportunity to remove sediment and while also removing mercury.
I'm a land use planning consultant in Nevada City working with the Nevada Irrigation District on the Combie Reservoir Maintenance and Mercury Recovery Project. The project included two components. First was technical. We worked with USGS, we worked with the Water Quality Control Board and Department of Fish and Game to come up with a project that would meet their objectives. And secondly, once we came up with that project description, we coordinated and interacted with neighboring properties who front on Combie Reservoir. Following those particular meetings, we met with the Placer County Municipal Advisory Council in Meadow Vista, and the outcome of those meetings produced a project that was much more beneficial and sensitive to the environment.
The process begins with a dredging operation at the north end of Combie Reservoir. The dredge removes sediments from the bottom of the lake and transports the sediments by a long pipeline to a land-based mobile treatment plant. The treatment plant consists of modular dewatering equipment and mercury extraction equipment. The system is designed to separate water and solids, at the same time extract heavy metals such as mercury and gold. At the end of this process, rock and sand are hauled away to an aggregate plant for use in construction. Mercury is transported to a safe disposal site, and clean water is returned to the river. The lessons learned from the Combie Reservoir Sediment and Mercury Removal Project will benefit several water agencies throughout the Sierra Nevadas, including scientists and regulatory agencies who are concerned about mercury-impacted water bodies. It is possible that this project can establish best management practices for the sand mining industry and other dredging-type operations where mercury is present in river sediment.
This has been an innovative engineering and scientific process from the beginning.
My name is Katie Burdick. I'm the Executive Director of CABI, the Cosumnes American Bear Yuba River Regional Water Management Group. We're a 39-member coalition group that's worked with NID for 2 years on their mercury extraction project. As a result of our collaborations over this time, NID has refined and revised project design, and the CABI members have learned a great deal about mercury contamination in the area. It's our firm belief as a group that as a result of this project, mercury that's currently contaminating the system will be removed, and that as a result of that, not only will we reduce environmental contamination, but the water agencies will also achieve greater dam capacity by getting rid of contaminated sediments.